So, okay, now we will see one more lecture in fluid mechanics and hydraulics. So, myself, Dr. Padala Shekhar, Assistant Professor, Department of Civil Engineering, School of Engineering, SR University. Before going to the next lecture, just we'll see the recap. So, recap of the previous lecture. So, hydrostatic pressure is a pressure exerted by a fluid at rest due to the weight of the fluid above. Then afterwards immediately we have seen calculated the pressure at a specific depth in water using depth and fluid properties and determined height of water column for a given pressure value and converted atmospheric pressure into equivalent fluid heights for water and mercury and found fluid heights for different pressure intensities in water and oil with specific gravity, and we have seen some kind of problems in this. This is the best one where you people need to learn Pascal's law. So Pascal's law states that the intensity of pressure at any point in a liquid, as I mentioned, intensity is different, pressure is different. In last class you can see. So pressure means you can see overview, but intensity means particular point. So intensity of pressure at any point in a liquid at rest is the same in all directions. Okay, and in a hydraulic lift, a small force on a small piston creates a large force on larger piston. Okay, so here you can see from one figure you will understand the clear picture regarding Pascal's law. In a simple sense, if you are using any kind of small force, like you just take the air pump when you are filling into a tube, you see the air pump inlet valve is small, but when you are putting the pressure it will go to the tube will be huge. It may be bike tube or car tube or lorry tube or else cycle tube. It will be huge you are sending out. So that means a small force you are applying with a small area, then it is affecting with respect to large area and output is large force. So you can take the example of tube. So in a hydraulic lift, a small force on a small piston creates a large force on a large piston, all because pressure is constant. So here the pressure is constant, that we have to understand. In a hydraulic, a small force on a small piston creates a large force on a large piston, all because pressure is constant. So applications, what are the applications of Pascal's law? As I mentioned, hydraulic brakes. You can see hydraulic brakes is also one of the application, and hydraulic lift is also one of the application. You can see some car wash, we can see the cars will be lifted up, and water supply system and water jet and sprinklers also one of the application, and dams and reservoirs. So that is also one kind of application. So another one is syringes. This is also one kind of thing. So applications, bigger the thing is that pressure is constant, all because pressure is constant. So it will be applications maybe like following as hydraulic lift, hydraulic brakes, water supply systems, dams and reservoirs, water jet and sprinklers, syringes. Now that applications we will see one by one. As I mentioned, hydraulic lift. So here uses water or oil to lift cars by transmitting pressure from a small piston to a large one. Okay, so hydraulic lift is nothing but uses water or oil to lift cars by transmitting pressure from a small piston to a large one. Next, hydraulic brakes means water or a brake fluid transmits equal pressure to all brake pads. So, okay, water or a brake fluid transmits equal pressure to all the brake pads. Next one, water supply system. In large tanks, oil or towers, pressure is equally transmitted through the water to supply all outlets evenly. So, water supply system means in large tanks or towers, pressure is equally transmitted through the water to supply all outlets evenly. Dams and reservoirs, pressure at any point in stored water acts even equally in all directions. See, that is what we will see in next upcoming classes. So dams and reservoirs, pressure at any point in stored water acts equally in all directions and uses for structural design. Coming to another one, water jets and sprinklers. So pressure is confined. Water pipes causes water to spray out evenly through all outlets. That means the pressure in a confined water pipes causes water to spray out evenly through all outlets. Syringes, like medical uses. When the plunger is pushed, pressure forces water based fluids to move uniformly. So syringes means when the plunger is pushed, pressure forces water based fluids to move uniformly. So everything here, hydraulic lift, hydraulic brakes, water supply systems, dams and reservoirs, water jet and springs, syringes, medical uses, everything is related with respect to Pascal's law application. That's what once again we can see. Pascal's law states that the intensity of pressure at any point in a liquid at rest is the same in all directions. Now, pressure measurement is a process of determining the force exerted by a fluid per unit area on a surface. So pressure measurement is a process of determining the force exerted by a fluid per unit area on a surface. So that is atmospheric pressure, gauge pressure, absolute pressure, vacuum pressure. Pressure measurement means in a simple sense, I think you people knows this thing very well, atmospheric pressure. These things also more or less related to with that. That is a gauge pressure, absolute pressure, vacuum pressure. Now we will see little in depth regarding the pressures. So pressure type and description. Atmospheric pressure, that is the pressure exerted by the weight of air above the surface, that is 101.325 kilopascals at sea level. And gauge pressure is nothing but pressure measured above atmospheric pressure. So pressure measured above atmospheric pressure. As I mentioned, everyone knows atmospheric pressure. Pressure exerted by the weight of air above the surface. And gauge pressure is nothing but pressure measured above atmospheric pressure. So gauge pressure is nothing but pressure measured above atmospheric pressure. and absolute pressure is nothing but total pressure equal to gauge pressure plus atmospheric pressure. That is nothing but vacuum pressure is also known as pressure below atmospheric pressure. So pressure above atmospheric is gauge pressure. Agree? Pressure above atmospheric pressure is gauge pressure, and absolute pressure is nothing but total pressure, that is gauge pressure plus atmospheric pressure, can be negative gauge pressure also. Now in a simplified way, absolute pressure always, that is total pressure equal to gauge pressure plus atmospheric pressure as we know, and absolute pressure is also known as atmospheric pressure minus gauge pressure, because negative gauge pressure also. So if it is plus, you can take gauge pressure. If it is minus, you just take vacuum pressure. So that is how we have to do. Understood? Absolute pressure is equal to atmospheric pressure plus gauge pressure, and absolute pressure is also equal to atmospheric pressure minus vacuum pressure. So find out the absolute pressure in SI unit when the barometer reading is 740 mm of mercury and the intensity of pressure is 40 kilonewtons. The specific gravity of the mercury is, so I think gravity is yes, that is equal to 13.6, and they have given, and the intensity of pressure equal to 40 kilopascals, and the reading of out of find out the absolute pressure in SI unit when barometric pressure 740 mm of mercury. Just try to solve this thing. So we have the data. Barometric reading is 740 mm of mercury, and the intensity of pressure is 40 kilopascals, and the specific gravity of the mercury is 13.6. Now we will solve. So atmospheric pressure, they have given 740 mm of mercury obviously, and gauge pressure, that is barometric pressure, gauge pressure they have given 40 kilopascals, and specific gravity they have given mercury, that is specially, that is 13.6, and find the absolute pressure. So we know one basic definition where we have seen just now, absolute pressure equal to atmospheric pressure plus or minus gauge pressure. So we will see two scenarios. First we will find atmospheric pressure, next we will go with gauge pressure. So atmospheric pressure equal to 740 mm of mercury that they have given in 740 mm of mercury that they have already mentioned in question. So 740 into 13.6 mm of water, that is nothing but 10600 mm of water. So P atmosphere is nothing but 10.6 meters of water, that is nothing but pressure head. 10.6 meters of water is there. So P atmosphere equal to rho GH, rho equal to 1000 into 9.81 into 10 power 6. So P atmosphere equal to 103986 newtons per meter square. So here we can see 1000 rho and 9.81 G and 10.6, just now we got atmospheric pressure. That is called P atmosphere is nothing but in terms of Newton per meter square 103986. Now coming to the gauge pressure. Gauge pressure, how much they have given? They have given 40 kilopascals. Agree? So 40 kilopascals is nothing but 40 kilo Newton per meter square. So Pascal is nothing but Pascal is nothing but 40 kilo Newton per meter square. So P gauge equal to 40 into 10 cube into Newton per meter square. Hence, so absolute pressure equal to atmospheric pressure plus or minus gauge pressure. Agree? Everyone will agree, right? Now absolute pressure equal to, what is the atmospheric pressure? 103910. We can see here 103986 plus Newton per meter square only. We converted again gauge pressure into Newton per meter square. That is 40 into 10 cube. That is equal to 40,000. So both you club 14,394 1,43,986 Newton per meter square. So now P absolute is nothing but 14.4 kilo Newton per meter square, and is also known as 14.4 kilo Pascal. 14.4 kilopascal. Now, class assignment, find out the absolute pressure in SI unit when the barometric reading is 760 mm of mercury and the intensity of pressure is 60 kilopascals. The specific gravity of mercury is 13.6. So only one thing I have changed, intensity of pressure, that is 60. Previously the intensity of pressure is 40. So just change 60. So the atmospheric pressure is 740 mm of mercury. So 740 into 13.6, that is equal to 10600 mm of water. That is 10.6 meters of water is constant for same another problem also. But the pi atmosphere is also same 103986. But just we have to change the gauge pressure. 40 kilonewtons means 40 kilonewton per kilopascals is nothing but kilonewton per meter square. 40 into 10 cube. Just we have to put 103986 plus 40,000. That is equal to 143986 Newton per meter square. That is 14.4 kilonewton per meter square. So this is 60 pascals. Here just instead of 60 pascals you go with instead of 40 pascals you go with 60 pascals. Kilopascals. Pascal is nothing but Newton per meter square. Just you keep it here 60,000. So here you keep 60,000. Then you will get one more thing, that is nothing but if I want to solve 14.4 light 16.4 kilopascals. So this will come 16.4 kilopascals. So try to do one exercise, it will be useful for you. So now the measurements of pressure, how the measurements of pressure is done. So there are two methods, one is manometric, one is mechanical gauge. So before going into it, we should have some basic definition. The various devices adopted for measuring fluid pressure may be broadly classified under the following two heads. One is manometers and mechanical gauges. Based on the principle of balancing a column of liquid, usually water or mercury, whose pressure is to be measured. So manometers is nothing but principle of balancing the column of liquid whose pressure to be measured, and mechanical is nothing but these uses mechanical elements like springs, diaphragms to convert pressure into readable movement. Bourdon gauge. So first one is just we will go with liquid column of liquid and we will go, but here Bourdon gauge. So springs and diaphragm. So next one, manometers, and we can see with respect to mechanical things. So manometer means simple manometers, differential manometers, that we will discuss next step by step. So simple manometers is nothing but another subcategory, piezometers, U-tube manometers, and single column manometers. So differential manometers, in a sense, two piezometer manometers, inverted U-tube manometers, and U-tube differential manometers, and micromanometers, and mechanical gauges, and Bowden pressure gauge, diaphragm gauge, deadweight tester, bellows pressure gauge. So in a simple manometers, piezometer, U-tube manometer, single column. In differential, you can see two piezometer manometer, inverted U-tube manometer, and U-tube differential manometer, and micromanometers. But this is different. This is, as I mentioned earlier, this uses mechanical elements to convert pressure into readable movement. So there are four things: Bowden pressure, diaphragm gauge, and deadweight tester, and bellows pressure gauge. Now we will see manometers. So like first half, manometers. So manometers are the devices used to measure fluid pressure by balancing the fluid column with another fluid. So often manometric liquid like mercury or water. So this thing, simple manometers is nothing but, in that first one, simple manometers, these measures the pressure at a single point in a liquid. So only at single point it will measure, usually in a pipe or a container. One end is connected to the fluid and another end is connected to the atmosphere. You can see one end is connected to the fluid and another end is connected to the atmosphere. This we can measure. Piezometer, a simple vertical glass tube inserted directly into the pipe or tank. See this one. So there is a tank, you should know the level of water. So if this level of water is keep on decreasing, here also it will be decrease. If it went up to here, again it will also go up to here. So it is very simple to sense the level of water. So these measures the pressure at a single point in a fluid. One end is connected to the fluid and the other is open to the atmosphere. So piezometer is nothing but a simple vertical glass tube inserted directly into a pipe or a tank. Now measurements of pressure is continued. Like piezometers are not useful for measuring large pressures in liquids like water because they would need very tall tubes which are hard to handle. So measuring large pressures in light liquids like water, they are very difficult. So also piezometers cannot measure gas, that you have to keep it in mind. It is not going to measure gas pressure because gases doesn't form a visible free surface like liquids do. And one more thing, these problems are solved by using a U-tube manometer. So this is a U-tube manometer, you can see. So that means first one, Piezometers are not useful for measuring large pressures in light liquids like water, because they would need very tall tubes. So it is very difficult, which is hard to handle. Also, piezometers cannot measure gas pressures because gases don't form a visible free surface like liquids do. And these problems are solved by using a YouTube manometer. And a U-tube manometer consists of a glass tube bent in U shape, and one end of which is connected to the gauge point and another end remains to the atmosphere. You can see one end is connected to the gauge and another end is remains to the atmosphere. That is what the how the U-tube manometer looks like. A U-tube manometer consisting of a glass tube bent in U shape. So that's what it is, a U shape. And as I mentioned, one end is with connected to the gauge, another end is with respect to the open to the atmosphere, and more accurate than piezometer. That's what they cannot go with large pressure. So it is the best in terms of overtaking the things with piezometer, suitable for both positive and negative pressure. Positive pressure is nothing but you can see the this is axis. If it is having more above, so that is called positive pressure. This is the axis. If it is touching, that is called below, that is called negative pressure. So we can measure the pressures, both things. Now measurements of pressure in terms of, in a YouTube manometer, when pressure changes, the liquid rises in one side and falls in other side. See, here another thing. In particularly, we are going with YouTube manometer. When pressure changes, the liquid rises in one side and falls in other side. The liquid rises in one side and falls in other side. So you have to measure two levels to calculate the pressure. This can be little inconvenient. So a single column manometer solves this problem. So you see, when pressure changes, here the pressure changes above, below. So you see here one height is there, here one height is there. So here one height is there, here one height is there. So you see, both times we have to measure. So in a U-tube manometer, when pressure changes, the liquid rises in one side and falls in other side. So you have to measure two levels to calculate the pressure. So it is inconvenient. It is can be a little inconvenient. So a single column manometer solves the problem like that. A single column manometer is a modified form of U-tube manometer. It's nothing but a modified version of U-tube manometer, in which a shallow reservoir having a large cross-sectional area as compared to the area of the tube is introduced into one limb of the manometer. So a single column manometer is a modified form of a U-tube manometer, as we know, but it is having little shallow reservoir. You can see what is this shallow reservoir. You can come here and you can watch this thing. See, there is a height elevation. We can go here and we can go to, but it is they created a reservoir, just modifying the U-tube manometer for our flexibility in taking in terms of readings, having a large cross section area as compared to the area of the tube. You see area of the tube and area of the reservoir, compared to the area of the tube is introduced into a one limb of the manometer. So here also same, but here we are having two axes, x bar, x dash, y dash, and this is called delta h, we call it as. And next one topic, differential manometers. So differential manometers are nothing but two piezo manometers inverted U-tube manometers and U-tube differential manometers and micro manometers. So they are nothing but two piezo manometers and manometers, inverted U-tube manometers and U-tube differential manometers and micro manometers. See, just we have gone through the thing called, see, different. First we have seen piezometer and we have seen some large area it cannot do. So we have gone to YouTube and after that we have seen that there is a reservoir, so it is simple. Now another one, two piezometer manometer, inverted YouTube manometer, YouTube differential manometer and micro manometers. After that we will see mechanical gauges. So now once we will see the glimpse, first we have seen the Pascal's law states that the intensity of pressure at any point in a liquid at rest is the same in all directions, and we have seen some applications with respect to hydraulic law, with respect to Pascal's law, that is hydraulic lift, hydraulic brakes, water supply systems, dams and reservoirs and water jets and sprinklers and syringes. And pressure measurements is nothing but is a process of determining the force exerted by a fluid per unit area on a surface. So there will be atmospheric pressure, gauge pressure, absolute pressure, vacuum pressure, but you can see the only one thing, absolute pressure is equal to atmospheric pressure plus gauge pressure. So absolute pressure is equal to atmospheric pressure plus or minus plus or minus gauge pressure. Gauge pressure is having positive means, that is gauge pressure, negative means vacuum pressure, that we call it as. And we have seen one problem, 740 mm of mercury they have given, 40 kilonewtons gauge pressure they have given, 13.6 specific gravity they have given. So atmosphere is nothing but 740 mm of mercury into 13.6 mm of water, then you will get 10.6 meters of water. Immediately P atmosphere equal to rho GH 1000 into 9.81 into 10 power 6. So we will get one value. Then gauge pressure is 40 kilonewtons. So just add it. Absolute pressure equal to atmospheric pressure plus gauge pressure. Then we will get 14.4. In a similar way, I have given you one problem, and that is nothing but intensity of pressure is 60 kilopascals. The specific gravity of the mercury. So here just you have to change the value and see 16.4 kilopascals. And measurements of pressure is nothing but manometers based on the principle of balancing a column of fluid, like mechanical gauges, column of liquid, it is manometers, and mechanical, that is Bourdon gauge. These uses mechanical elements to convert pressure into readable moment. Now manometers are simple manometers, differential manometers. Simple means piezometers, U-tube manometers, single column manometers. And differential manometers is nothing but two piezometers manometers, inverted U-tube manometers and U-tube differential manometers and micro manometers. Now mechanical gauges is nothing but Bourdon pressure gauge, diaphragm gauge, deadweight tester and bellows pressure gauge. So we have given a simple thing. Simple manometer is nothing but at simple single point they will measure, and piezometer is nothing but with respect to the tank they will do. And piezometer having some drawbacks, that is large variations, and that we have sorted out with respect to YouTube. But even though YouTube is having both things, positive and negative pressure, but after that YouTube also is having some inconvenience. Again we went with respect to the modified YouTube manometer, that is nothing but single column manometer. Then we have seen differential manometers, two piezo manometers, inverted U-tube manometer, and U-tube differential manometer and micro manometers. So we'll see in next class.